Hello everyone. Today we will talk about area of composite figures. When we say composite figures, these are figures that is composed of two or more shapes. In this particular video, we will talk about composite figures that are made up of squares and rectangles only. The figures that you will see in the video are not drawn to scale, and all the lines that you will see meet at a right angle. Let's try to look at this composite figure. What shapes do you see? Well, I can see squares and rectangles. Okay, can you see that also? Alright. So one way to get the area of composite figure is to cut the shape into shapes that you're more familiar with. Get the area of each of those shapes and then add the areas. So let's try first making this into two shapes. Okay, so I will call this area as A and then this one B. All right, so let's call that method one. So next would be finding the dimension of each of these shapes. We remember that when there are tick marks, it means those sides with a similar tick mark has the same length as the other side that has the tick mark. So for this one, we have 2 meters here. So meaning to say the other ones with the tick mark is also 2 meters. Okay. So for A, that would be 7 by 2, 14 square meters. And then B is 2 by 2, 4 square meters. So the area would now be the combination of A and B. So 14 plus 4, 18 square meters. Okay, aside from this, okay, I know some of you did not cut the figure into a square and rectangle. Maybe you saw two different rectangles, right? So let's try to do that also. Okay, so two rectangles. Maybe you cut it here. Okay, so A and B also. I'll use a different one for that. Method 2. So we have here the A is 5 by 2, which is 10 square meters. And then B on the other hand is 2 meters here. Okay, but we have to figure out how long this side is. What would help us find the length of this side? Okay, so this side, of course, is parallel to these two sides here. So when we combine these two sides, actually, if you want to visualize this further, we can actually move this. I'll color it blue. If I move this side over here, can you visualize that? It would actually be the same length as this whole thing here. Okay, so these two long lines are of the same length. So meaning to say, I can just add 2 plus 2. This side right here is 4 meters. Okay, so I can get the area of B now. B will now be 4 by 2, 8 square meters. So then, the area of the figure is still 18 square meters. Okay? Maybe there's another way. Can you see one big rectangle and then a small rectangle being removed from that big rectangle? So let's try that method out. So this is the big rectangle I was talking about. Can you see it? Okay. Then I have this small rectangle inside. Do you have an idea now how I will get the area using these big and small rectangle? So, we will be getting the area of the big rectangle green and then the area of the small rectangle, small red rectangle, and then we will be subtracting. Why? Because this red rectangle is not part of the area. So we have to remove that. So let's see if we will get the same answer from that. So I'll call that method 3. What are we going to do? The area of the big rectangle, 7 times 4 is 28 square meters. And then the small rectangle is 5 by 2. 5 times 2, 10 square meters. And then we're going to remove it. 28 minus 10 is 18 square meters. So there you have it. We have the same answer using 3 different methods. Let's try another one. We have here a problem. John has a garden. He used a part of it to plant chili pepper. Find the area of the remaining lot. For this particular problem, we cannot try the splitting the figure into parts. Why is that so? Because if I split this figure, if I split this figure into, say, a rectangle, okay, 3 rectangles, I wouldn't be able to know how much or what would be the length of this side. Okay? Or what's the length of this side right here? I cannot assume because there are no marks or markings that will let me know what the area or what the length of those sides are. Okay, so sometimes a method would not work with a given problem or figure. So let's try to find another way to solve for the area of this. Alright, so I think the best way to solve this is to find the area of the big rectangle and then remove the area of that part that you planted chili pepper on. Okay, so getting the area of the big rectangle is 6 by 5, 30 square meters. So that is the area of the whole garden. And then the area of this small rectangle where he planted the chili pepper, 3 by 1, that's 3 square meters. So the area of the remaining lot will now be 30 minus 3, 27 square meters. Okay, so that's it for this video. I hope I was able to help you. So see you again on the next one.